So let's talk about some problems we have when trying to observe. One problem is that most telescopes are ground-based, which means we have to deal with weather. You can't see anything when the sun's up, and you're not going to be able to see anything if it's cloudy, and you really don't want to be pointing your telescope up into the sky if it's raining. And so astronomy is actually a weather-based science, meaning that depending on what's going on with the weather will determine whether or not you're actually able to observe or not. Now, another problem we have in astronomy that's becoming a much bigger problem in recent years is the problem of light pollution. So we mentioned earlier that as sunlight hits the atmosphere, it scatters. Well, it's not just sunlight. Sunlight's not special. This happens to all light. So as that light scatters, it will then cause problems trying to see very faint objects. I love these two images. Okay, so in this first one, you can easily see through here, we've got the Milky Way. And then somebody turns on the porch light and you can't see anything anymore because of the sky glow from the air pollution. Okay, so we also have to start worrying about air pollution. In other words, please turn off your porch lights at night. Now, another problem we have is just the atmosphere itself. Even if you have a very clear night, the air itself is in constant motion. If you've ever been on an airplane and experienced turbulence, turbulence is where the airplane is shifting and rocking, and that's because of the motion of the air around the airplane. Well, it doesn't just affect airplanes, it's going to affect light too. When the light first hits the atmosphere, it's actually pure and crisp and beautiful. But as it passes through, the turbulence of the air actually refracts the light, bending it this way and that way, jumbling it up, so that by the time it actually reaches our telescope down near the ground, it's already kind of jumbled together. This is actually why stars appear to twinkle. If you've ever looked up at the sky and you've noticed how the stars are twinkling, it's because of the atmosphere. The air itself is going this way and that, refracting the light this way and that, causing the stars to twinkle. It's so much... it's so many people have noticed it that we even have a song about it. Now, this turbulence of the atmosphere means that there's a limit to the angular resolution we're actually able to get. So the light is bending this way and that way, refracting this way and that way, becoming blurry. So here in this image, we have regular atmospheric distortions, and it appears like we only have one object. However, when we actually take out those problems and get a much better angular resolution, you can actually see that there are in fact two different objects. And so the atmosphere actually affects the how good an angular resolution you can get. The observing conditions are what we often refer to as seeing, the seeing conditions. Now, to overcome these problems, there are some things we can do. One, we can build telescopes on the tops of mountains. On the top of the mountain, we're looking through the least amount of atmosphere, which means we're going to get the least amount of distortion. Something else we can do is we've actually developed technology to help us deal with these problems. So this is what is known as adaptive optics. The idea is that we produce our own spot of light in the sky using very powerful lasers. Now, because we made it, we know exactly what it should look like. So we bend and flex our mirror until that light source that we made is the exact right shape. Once it is the exact right shape, that means that we've bent and twisted the mirror to take out all of the effects of the atmosphere as the light is passing through, which means that we've gotten rid of most of the atmospheric distortion. Now we have to flex and change the mirror in real time to take out all of these problems. So we have actually developed technology to bend and flex mirrors in real time to help us get rid of the effects of our atmosphere. This is absolutely amazing. So to help get you a kind of a feel for how awesome this adaptive optics is, here we're looking at a rich star field, so a region that has lots and lots of stars all close together. On the left square, this is without adaptive optics. So with just a normal telescope, you can definitely tell there are stars there, probably quite a few because of how bright it is. but you're not going to be able to actually count the number of stars. On the right is what we can do with adaptive optics turned on. Now we've gotten rid of all of the turbulence of the atmosphere, and we can start to count individual stars. Adaptive optics is absolutely amazing. All right, here is question number 4. If you were on the moon, would you see stars twinkle? A, yes, B, no, or C, we have no way to tell. Go ahead and think about it, and we'll discuss in just a bit. All right, if you were on the moon, could you see stars twinkle? The answer is no, stars don't twinkle on the moon. The reason why? The moon does not have an atmosphere. It's the atmosphere around the Earth that us who dwell on the Earth, as we look up through it, causes the stars to twinkle. So if you're on the moon, stars don't twinkle because there's no atmosphere.